Hi everyone, my name is Nanapu Sirisha. I am studying in 5th semester in Computer Science and Engineering in Sri Venkateshwara College of Engineering. Today our subject is TOC, Computational of Theory. In this subject we study about the remarks on context-free grammar with subregular control languages. First, we study about the abstract. A context-free grammar with control language is a pair where GR is the definition and G is context-free grammar and R is the regular set of over the set of prediction of G by strictly locally. K is a test table where K less than or equals to 2 and ordered union free and ordered and regular circular control language. We have no loss in this generative power. We generate the same families which is obtained by the ordinary regular controls. Introduction. In this, we have mentioned that can be considered as a continuous of a other investigation necessitating the effect of subregular language to the non-generative power. It is transformation of non-determinative infinite automata into determinate finite automata. It is a natural problem to study the generative power of context-free grammar with control language, where the control language belongs to the subset of the set of regular language. This first step in this direction we have done in this paper, where it was shown that context-free grammar with modal, combinational, definite and Napoleon's control language generate it is regulated, that is sequence of production used in derivation as belongs to a regular language called control language. Next is definition. Definition. V is the infinity non-empty set. The set allow word and non-empty word over V are denoted by V into and V plus respectively. The empty word is denoted by lambda for its language L. The alpha L be the minimal set of V such that L less than or V into. The power of set X is denoted by X. The families of infinity, regular and context-free grammar are denoted by Fi and regular and Cf respectively. Furthermore, let Fin and lambda and Cf minus lambda be the families of all infinity and context-free language which do not contain the empty words, where subregular family of language is. The aim of this section is the definition of all the subregular families of language considered in this paper and the relation between them. It is the combinational if it can be represented in the form of L is equals to V into A for some subset A through V. The variant of context-free grammar with control and appropriate checksum is a partial interest size regular is equals to the set of all respectively enumerable language. Next is context-free grammar with control language is the context-free grammar with the control language is the pair G and R, where G is equals to GTPS is a context-free grammar and R is the regular language and P is also called control language. Next is cases where only context-free language are generated. We start our study with the commutative languages like theorems. First theorem we study about the we have com is equals to cf. Let L is equals to com, where there is a context free grammar and G is the definition and it can be commutative regular set RCP such that GR is equals to language with any rule P is equals to A and lambda. We associate to a rule P is equals to A truth lambda P. Let P be the set of all the associative raw in the constructing context-free grammar. It has been by using the definition we start the solving the problem. This is the formula to find the given problem. Next is we have SLT1 is equals to CF. Let SLT be the language. There is a context-free grammar and G is the definition and is strictly located one testable language. R is equals to AB into C such that language is equals to language GR for each P is equals to S truth lambda. It has derivation has to start with the rule on left hand side and the right hand side. It can assume that the all rule in A is the yes at their left hand side. It is S is an additional symbol not in NUT. We consider it as one first to apply the rule with and then can be applied only rules of B. Next is case generation. We recall the notation of a matrix grammar and its associative language and their relation to grammars with control. The context-free grammar is a pair of G and M, where G is the definition is a context-free grammar, M is a infinity set of sequence of elements of P. We say that X NUT into derives the by an application of matrix. It is denoted as X truth Y. Next is the lemma 5. For any language we use the language truth REG where the context free grammar G is the language and P we all rule P N or parallels. It is known as the matrix grammar. There it has been sufficiated and it has the moreover the rule of all matrix and it has and it also be the matrix of on all length of parable. It also be the M is be the set of all matrices considered in this way. Next is the summary and conclusion theorem term. For finding any k less than R2, we have the fin on 7cm on mon, com, diff and nil. We mention the theorem strengthens the impairs obtained by grammars with other type of regular if the divorce use terminals and the generate language over the terminal alphabets. Then the hierarchy of language families obtained by the subregular regulation mechanism differ essential form. In this combinational if it can be represented in the form of L is equals to V into A for some subset A truth 1. The variant of context-free grammar with control and appearance checking is special interest size regular is equals to the set of all recursively and enumerable language. Thank you. Collaborating and k less than R2. We have this is the formula to find the problems where fin truth it has infin. Thank you.